This is Durney's factory, Lotus International, in Norfolk. This visit is supposed to be part of his study, but for Ben, already dubbed by some observers the next Colin Chapman, a visit to Lotus is like a pilgrimage to a shrine.
Yes, hello, I've come to see Frank Durney.
Yes, can I just have your name, please?
It's Ben Bowlby.
Take a seat and I'll let him know you're here.
Thanks.
He's on the phone.
All Formula One cars are limited to quite a small amount of space at the back.
Yeah.
We're only allowed 1 metre wide.
Yeah.
And the diffuser isn't allowed to start ahead of the rear tyre. So the amount of diffuser we've got on the car is very small and very much limits the amount of downforce in proportion to the entire downforce.
Sure.
The proportion we have for underneath the car is probably less now in Formula, but it certainly is less than when we had sliding skirts.
Yeah.
And most other Formulae, Group C or any of these sports cars have got so much more space, like you provided, that the proportion of the downforce you can get from underneath is much greater.
And, I mean, one of the sort of questions I've got is whether I'm going to be able to run without a wing. Now, maybe that's daft. And the thing is, we've only got 165 horsepower.
You won't be able to run without a front wing.
No.
Front and rear wings help hold the car down, but they create drag and therefore absorb power. So designers try to induce low drag downforce by shaping the underside of the body into a diffuser.
Yes. Well, there's not really very much you can see, but if you look here, we have a sharp fold there, and we also have some sharp-edged strakes which have been touching the ground, so you can see they're a little worn. Yeah. Now, everyone, I think, has their own theory, but certainly the flow is extremely three-dimensional in this area, and it's influenced by all the rest of the flow of the car. So, starting at the front, you have the front wing has a huge influence. The upwash from the central portion of the front wing has a serious detrimental effect on the rear wing. Right. So that's why a lot of people now are cutting away this middle bit of the wing. It helps this bit here and here. If they get more downforce from the outer edges, the upwash from the outer edges isn't detrimental for the rear wing, and it also helps the cooling.
I thought it was only for cooling. I see it's
well, you'd be surprised. I mean, I think that's probably why people first tried it.
Yes.
But were then absolutely gobsmacked by the fact that they got actually better lift-to-drag figures. The other really seriously detrimental thing you have on the front wing is the wingtip vortex, in that you're not allowed for these to seal.
No.
So you do get a quite strong vortex from the front wing, and if that goes in the wrong direction, the loss of mass flow you get through some of the important bits of the car is serious. So people have put turning vanes behind wheels, changed side pod shapes and what have you to try and get that vortex to go round the outside of the rear tyre rather than on the inside.
So,
yes, yours will probably work.
I'm trying to stuff it out.
Yes, I would say.
The rads go in front. In fact, you can just see them sitting in there.
Well, I think in that you were wrong. In simple terms, if you leave the radiator there, the air is going to wander along here and say, whoa, goodness me.
Sure. I mean, I've got to build an entire ducting structure around the front of it. The question is what shape?
Well, you need a diffuser.
This diffuser duct slows air down, crucial if it's to pass through the tiny mesh of a radiator core.
Speeding it up again.
You've got to match the core resistance to the free stream flow. With a heavily resistant core, if you didn't have a duct, why should the air go through that?
Not at all,
And particularly if it's an angle. If it was square to the flow, the duct probably wouldn't make very much difference. But if you want to run it like this, the duct is very important and quite difficult.
If the air isn't, as you say, sort of flowing, it's not a flowing situation, why do you use radiuses like this?
Well, there is flow. Yeah. You do, in these local areas, you get low pressures due to the radiuses and various other bits and pieces. It isn't, and there's drag. You wouldn't put sharp corners anywhere where they weren't going to give downforce because of them being draggy. It's sort of more or less flowing almost parallel to the centre line of the car here. As you get closer to here where the more downforce is being generated, it gets much, much steeper. So it's sort of flowing in this direction here.
Right.
And so in fact, the flow is going in and it's being tripped by the strake that's under here. I don't know whether you can see that. The strake there. It's at a fairly acute angle to that, and that makes a vortex. And I believe also there's evidence there's a vortex on the sharp corner, but In a typical situation with the new car, more than half of the drag is the wheels and tyres. The wings, bodywork, and everything else is only contributing about half. So if you double the efficiency of the bodywork, you'd only lose 25% of the drag of the total vehicle. So it is a bit of a limit now with an open-wheel car.
Right.
But putting fairings and things on it is normally so detrimental.
The rules in clubman racing, Ben's category, insist that the rear wheels have mud guards, so Ben has enclosed them completely. This won't matter as long as Ben isn't misled by mere styling.
Sort of non-engineers, even quite a lot of stylists, will actually draw a sort of swoopy-looking car inside view with a very raked windscreen and all that sort of thing. And all that does is generate some upwash and downwash and lift. Whereas those cars which are actually aerodynamic are the ones that are aerodynamic in plan view. Things like Saabs, the older Saabs and Citroens, are actually much more aerodynamic than most of these swoopy things that have got lying down windscreens with sharp corners. They're appalling. I mean, things like the Lamborghini Countach. Well, the original Esprit that's been replaced by the new SE was very angular, looked very stylish, but probably isn't certainly not as aerodynamic as a new one. But anyway, we now have at the back here a two-element wing. This one is used to mount the whole thing on as well, so it's structural. But part of
The improbable stack of rear wings on a Formula One car are more like turbine blades than conventional aircraft wings.
shape and where it stops are all related to each other to get optimum performance from all three, because they all help each other.
Part of their job is to act like an extractor fan, sucking out the air that exits from the diffuser on the underside of the car.
Sort of conflicts between the wings. I mean,
Oh yes, it isn't easy.
No,
Oh yeah, I think that if you were to guess, like a lot of things in motor racing, you guess and you think to yourself, oh well, I'll try this and it's bound to be better, and it's much worse. And then you often learn from that, because you then have a big fiddle around to find out why it was worse, and you often learn.
That's the sort of learning Ben likes. He arrived at Lotus deciding not to try rear wings. Now he's not so sure.
If you're going to use a very short chord wing, which is very wide, which is far and away the most efficient, a central mount will not be enough. You'll need to support it, certainly, because you won't structurally be able to make a sensible wing, which is only supported in the middle.
I am going to make my own wings, because I basically can't afford to have them built. What
They'll
would
be
you
quite
reckon?
difficult.
Very difficult. What would you reckon would be the best approach? I mean, I haven't got sort of...
We could help you out a little bit on that. We know how to make some wings that don't use pre-preg, so.
That would be fascinating.
But the position of the wing, relative to the body, fore and aft and height-wise, will be worth making lots of holes in your mounts for. Because you're not going to be doing a great deal of useful wind tunnel testing, I imagine, and therefore you have to do it at the circuit. The stopwatch tells you whether it's better or worse. Whatever the driver says. Whatever the speed trap says. Whatever anything else says, the stopwatch...